Hello everyone, welcome to another problem. So we are going to do this problem that comes from JEE Advanced Phys paper 1 from 2020. Turns out that looks like a complicated problem, but because over here it says you could think of them as ideal gas, okay, dilute ideal gas. If you read this problem, consider the collection of molecules to behave as ideal gas. That kind of helps. So what we can do is think of these molecules of potassium permanganate. So we could see is like a, forget this open thing, just like a close this everything, and you have two closed containers, and you have some gas here with this number of molecules over the volume equals to N1 this side, and number of molecules per volume equals to N2 this side. And think of this as a this just ideal gas, each one of them. That makes a big deal of difference. If it's truly ideal gas, there will be no viscous force, but they want you to be actually think of a viscous force on each molecule when it's flowing. Okay, so the gas, these molecules will flow from higher concentration to lower concentration, but their speeds will be kind of tempered because of viscous force. All right, both of these are same temperature, and another condition is that the density difference between them is delta N, which is defined N1 minus N2, and this is supposed to be much less than the concentration N1. So N1 and N2 differ by just a tiny bit. Okay, and you're supposed to, so if you say N1 minus delta N is equal to N1, or N1 plus delta N is N1. In the formulas, if you're comparing this with this, you might be able to do just that. But they don't want to just completely do this all the time. They want, if you have to expand it, so suppose you had to expand N1 around N2, so you have N2 plus delta N, right? But if you have to N, maybe N1 plus some A delta N plus B delta N square, if you are to expand like that, then you're supposed to ignore these guys. Okay, so you're just keeping up to delta N, and K sub B is Boltzmann constant and beta is a constant, and for the length of the tube is L and the cross section is capital S. So those are the things given. All right, let's look at each word of the question and see if we can answer them. All right, just clean this up. So question A says the force causing the molecules to move across the tube is this, and over there it says the force is coming from the pressure difference between the two. So let's look at the tube. So the connecting tube is that, and that cross sections area is S. So on this side the pressure is P1, on this side is pressure is P2, So the force will be, this is P1 is greater than P2 because density is more than that. So the force on, let's call it, things inside X is going to be P1 times the surface area, that's the force on that side, minus P2 times surface area. As well as P1 and P2, those are partial pressures, but here I'm just supposed to think of them as ideal guys. So PV equals to number of molecules times kBT. This is the same thing as in RT. This is in moles. And we're going to talk about this is the number of molecules. So if I do V on the other side, so this puts N over V, that's what these guys are. That's why I'm using molecular form, okay? So this will be, now this is not, so this will be P1 N1 kBT and P2 will be N2 kBT. So this will be N1 minus N2 kBTS, and that's delta N kBTS, and that's correct. So A is correct. Next is force balance implies this. Well, so the viscous force is in all the molecules, so we have to kind of add them up, right? So this is the external force and then the internal force. They're gonna have to balance on each one of the molecules, right? So we look at how many molecules are there. Okay, so what is the density of this? Well, we can say one molecule, you have viscous force. If viscous is equal to if this was the if this was the x direction, then viscous force will be minus beta V I hat and external force, one molecule, is this delta N kBTS I had all molecules. So I need to somehow add this up. So this one, when it's velocity of one molecule, maybe if you look at like one of the molecules, so x-axis, this is L and this is 0, is some point x. This molecule it has a velocity v, so that depends on x. So that depends on where it is, right? The velocity will depend where it is. And if I want to add up all these molecules, one way to do is we need to have F on everybody here. So we can do average, a viscous average, just the magnitude part. Let's look at that. Equals beta V average times number of molecules in tube. So we have a beta V average, let's put a bar for average. Number of molecules will be, well, the density over here is nx, then this will be I have to think about number of molecules at some average density in the tube. So this also, let's keep it average because that's easier to think in terms of n average. Well, what's n average? N average will be, we're talking average V times n together. And that can be quite complicated, depends on what the distribution is. So one way to think about this will just be n1 plus n2 over 2, something like that. So I have n1 plus n1 minus delta n over 2. So this is n1 minus delta n over 2. And it's because this thing is much, much less than this, so we can just mark it n1. So all the molecules, viscous force, all molecules must be balanced by the external force. So there's no acceleration of any kind, right? Not internally, not externally. So it's going to be beta V average and n average L equals to delta n kBT S n average L times S, because we're going to have the volume, got to multiply by the volume to get the total number of molecules. So this is S. So calling V average a V, n average is n1, this is V, but S cancelling out, delta n kBT. So this also is in the approximation that we're dealing with. This is also correct. Now total number of molecules going on average. So we can use this beta, this V, to figure out how many molecules will go across. So this is actually kind of, so if you have a V and this is the speed which is molecule is moving, and how many total molecules, we just have to multiply by n1. We've in the same approximation in average n1, and how many are going per unit, multiply cross section. If you look at all of this, this would be number, look at the units, number over volume, and this is area of cross section times length over time. So this is the number per unit times this length got calculated. So unit wise number per unit time. So this tells you how many will cross, right? You can actually do this because of V, this distance V, anything, and this is S, anything in this volume will cross in unit time. So from here you can actually do calculation. You will get a delta n over L going on the other side, kBT over beta going on the other side, and multiply by S. So this is expression for things that should go in unit area, unit time, and that's the same expression that's also correct. So this actually is coming from that. So it's not a new problem. How about D? Rate of molecule getting transferred through does not change with time. You can see this is the average rate. Depends on, you can go any one of these. This is the average rate and depends on delta n. And delta n will be changing because n1 will be going down and n2 will be going up. And so delta n is changing. So this says does not change. That means incorrect. So this is, all of these problems are basically coming from here. You know, as long as you do B right, all of them will be follow from it. Okay, this was not, I think it's okay problem, and it's like a little physicsy problem and a little bit of approximation involved. But I think more or less it's a doable problem. Okay. Well, I'll see you another problem. Bye.